Hello everyone and welcome to the first part of making a PCB at home easily. In this video I will talk about designing your PCB, but I won't talk about how to use the software because there is a lot of different softwares out there. But I will talk about guidelines, tips and tricks while designing a PCB for home production. The video is divided into chapters if you'd like jumping into a point directly, and let's get started. So as I said before, there are lots of softwares out there for PCB designing, but in my opinion the best are a software called Eagle and another one called EasyEDA. You could use online version if you'd like, but you could just download a compatible desktop version. In this video I will be using Eagle software, but don't worry if you are using another software because they all share the same key points which I will talk about. I will start by creating a new project in Eagle, then I'll make what's called a schematic design. A schematic design is just the design where you declare which points shall be connected to each others, maybe points on a microcontroller, a transistor or just anything. Here each component has a certain symbol, and you can actually share this design to anyone and they would understand it and could replicate it. These are, for example, resistor symbols where you could just connect them using green wires in the direction you want. The first thing to do while making your schematic is actually picking the components you want to use, but there is a very important thing, which is when picking a component you should be sure it's the right shape and size. Not talking about the symbol shape, but about its real shape. Here's for example the AT-Tiny13 IC. You can see that there is many shapes and sizes for it. Some are SMD and some are through hole components, so you should be sure about what you are picking because it's important. Then just repeat this process of checking everything for each component you add. Of course, each component has its own name and its own value which you could change, and it's preferable to actually do so. But in my simple circuit, which is by the way an AT-Tiny13 programmer, I don't care about that. But in more complex circuits, you should definitely change the values and the names to more suitable for your own PCB or whatsoever. After that, you start connecting the points you want in the layout you like, but please revise your connections, because you really don't want to mix up something. That's why you shall look up data sheets to be sure for what you're doing, by the way. And at the end of your schematic design, you might add some text, export the schematic and share it to someone, and so. Now let's talk about the board design, which is interconnected to the schematic design you made or will make. Here in the board design everything is important. This is going to be the shape of your PCB, and here comes the limitations of your design. First and most important thing is that to lay out your components as near as possible to each others to facilitate everything. Also keep in mind that in our design it's going to be a single copper side design. That means the copper traces which will connect everything will be only in one side and will be just two-dimensional, so you can easily jam everything. Also keep in mind that you are not a PCB factory which could manufacture any design you make. You might be restricted to a certain shape or a certain size or just certain parameters in your PCB design, so be aware of that. Routing is the process of connecting two points which are connected in the schematic through copper traces. You can see that there is yellow wires everywhere here in Eagle software, which indicates an unrouted connections. So you should connect those connections using copper traces manually, or you could just leave the auto router to do it for you. And here comes the first design limitation of your PCB due to manufacturing, which is the trace width and the clearance. Your trace width or the copper trace width should lie between 0.4 mm by minimum and maybe 2 mm by average. The clearance, which is the shortest distance between two adjacent copper traces, should also lie between maybe 0.5 mm and 1 mm by average. Because while manufacturing, you should be ready for faults which you will need to manually fix with a pin. So making everything super small will be bad in such a situation, but if you got the right hand and tools, definitely go for low values. Beside your own tools and manufacturing limitations, there is actually electrical limitations, where for instance you should definitely use a thick trace for high voltage line or very relatively thin traces for signal lines for instance. I also recommend that the first PCB you make should have maybe 0.8 mm thickness and 0.8 mm clearance, which will be good enough. You might use an online calculator to see what is the minimum width or clearance of your circuit, but I just get it by sense. I will now manually route these connections using some thick width copper trace. It's preferable not to use right angle traces because they can emit radio interference in FM radio PCBs or very fast computer boards. You could use 45-degree traces, which would be legit, or if you could do it, just use smooth traces, which are actually better, although some people might argue it doesn't matter at all. You might also use what's called a ground plane, where all of the rest of the PCB is just a big ground plate, which also helps filtering radio signals and maybe electromagnetic interference and stabilize things up. But I will not do this in this circuit. Well, I will not lie, I'm actually lazy and I just leave the auto router to do it for me. And after some time, here is the results of the auto router. Unfortunately, it couldn't do all of the connections due to the jamming that happened. It could happen to you even if you do manually. Route manually, you could get jammed. And at this point you would put and place the components in a more efficient way, but I will tell you what to do if things just go horribly wrong. Well, you have actually two options. One, just ignore it and at the end of the manufacturing and in the soldering step, just solder a wire connecting these 2 points. Or two, design small holes or imaginary vias where you can insert wires and solder them professionally, something like this. I'm from the future and I'm here to tell you that the board I will be making is probably the worst board I have ever made in my entire life. But before unsubscribing, and by the way, if you're not subscribed, subscribe because I will take this as a big advantage. I will show you each problem, how I'll solve it and how I dealt with it, because probably the printer got jammed and the chemicals didn't go well, but anyway. And that's the end of this video. I really hope you enjoyed it. If so, don't forget to like it. And if you have any suggestions, questions, just drop me a comment below. And tell me if you really would like me posting a half an hour video, for example, talking about how to use Eagle from scratch. Stay safe at home and thanks for watching. I came from the future. I'm here to tell you that. I'm here to tell you. I'm from the future and I'm here.